Hello class, so today we're going to look at the Pearson's product moment correlation coefficient. So just to get us started and let you know what the Pearson's product moment correlation coefficients are, these are measures in terms of R and they measure how closely a line of best fit can be drawn to the actual data points. Now we're going to use our graphical calculators, and what we're going to use is we are going to use data on the maximum temperatures in Manchester, which is going to be our X values, and Southampton, which is our Y values for the year 2011, all the way down from January the 3rd all the way down to December the 3rd. And you can see we've got two sets of data. So we're obviously going to use our graphical calculator today. This is the point of the video. And we're going to go to obviously statistics mode. So I'm just going to get myself into that. And you've got two lists of data. So it makes common sense to have the list 1 to be my X values and the list 2 to be my Y values. So the first things first is I'm going to enter my data. So I'm going to show you the data so you can do it with me. So in my list 1, I'm going to do 2, 9, 7, 12, 15, 24, 23, 25, 19, 24, 16, and then 10. So as you can see, in my list 1, I've got the data that I've just entered. Now in list 2, which is there, I'm going to now enter my Y values. So I'm going to move my cursor across, and it starts back at the beginning. So for term 1, we've got 3, 9, 5, 13, 15, 24, 21, 24, 19, 22, 16, and 12. So as you can see, we've got two lists of data with the information in. Now we're going to do obviously a calculation, so we can press F2, and we're going to need to go to set. So this time you need to make sure that for two variants, your X list is obviously list 1 and your Y list is list 2. Now if it's not, what you just need to do is, you can see there's little F parallel with F1, you've got the word list. So if you press that and you just write down, so it's got list 1 to 26, we obviously want list 2 for the second one, and we're just going to press the EXE button. So as you can see, we've got the correct thing. So for two variants, list 1 and list 2 is what you want. So to get out of that, we're going to press the exit button. And as you can see, you've got set, you've got REG, 2 var, or 1. So we're actually going to do something to do with the variance, not the variance, sorry, the regression line. And to do that, we need to press S3. Now, as you can see, you've got X, you've got MED, you've got X to the power of 2, X to the power of 3, X to the power of 4, and then so on. We're just interested in just X on its own today, so we're going to press F1. And then you've got two things. You've got AX plus B or A plus BX. So we want, our regression line is written in AX plus B. So we're just going to press the F1 button. And as you can see, you get given that the A term is 0.91, B is 1.01, the regression is 0.98, and the R squared, so regression squared, is 0.97. Now, for your actual exam, you are expected to, and I will show you this now, as it's got the example in the book. As you can see, this is what you're expected to be able to do in the actual exam. So this is the exact value, so I'll show you again. So this is our one, and this is the one we've got in our graphical calculators. They are identical. So the question was to use the calculator to make sure that you get the product moment correlation coefficient is 0.897, which we have there, so R. And then it asks you to comment on your results. So I'm going to show you the answer to help you out. So this says, this implies that there is a very strong positive correlation between the temperatures in Manchester and the temperatures in Southampton. Thank you, class. See you later. Bye.